Alright, what we did is a force just pointing up or a force just pointing to the right. What if my force is pointing in some general direction? In this case, Fx, the x component of force, will be the projection of this force to the x-axis. You figure out if this line parallel, if this dotted arrow is parallel to the x-axis, how long it should be. Then this is your Fx. The rule is that you need to make a right triangle here. And for the Fy, it's the same, but in the y direction. The rule is that you need to make a right triangle here. And if you have a general force in a random direction, you just take the projection to be Fx and the projection to be Fy. And they will affect the acceleration according to Newton's second law. Let's practice some trigonometry. If this angle is theta, what will Fx be and how is it related to F? This is not equal yet. What will Fx be if this is theta and this length is the force you apply? Good. You are taking the hypotenuse to the adjacent side, so you are taking the cosine. How about the y component? Good. You are taking the hypotenuse to the opposite side, so it's going to be f times sine theta. So that's how you go from a force to the component, and you go from component to acceleration, and you go from acceleration to a BT graph. Then under the area of the BT curve, you get the displacement. The initial velocity and initial position depends on how you set up your frame and what the problem tells you. Either you throw it off a cliff with some initial velocity, or you start from rest and you start it from this height, and then you can get the initial conditions. So that is Newton's second law when we have one force. You decompose it to x and y component, and they will affect x and y acceleration respectively. Any question? Now, what if there are more than one force acting on the particle? You can have more people pushing the chair at the same time. I can just push the chair with two forces just by myself. So what if there's two forces acting on the particle? If you have two forces acting on the particle, let's say you have the first one called F1 and the second one called F2, then you need to compute the total force for the Fx here. Total force is the sum of all the forces. If you have two forces, then it will be the sum of the x component of the first force plus the x component of the second force. Does that make sense? Therefore, if you have a particle, one guy is pushing to the right, one guy is pushing equally hard to the left, the total force, let's say this is the x direction, y direction, so the force is in the x. F1x is going to the positive x, so it is positive F. What will F2x be? This is F2. This is F1. If F1 is pointing to positive x with magnitude F, then its x component will be F. How about F2? It is going to the negative x. What will be the x component of that F2? If you are going from here 2 and you're going to 1. If you are going to 2 to 1, what is your x displacement if this is meter? Negative 1, right? Because you are going to the negative x direction. So what will the x component of this force be if you are going in a negative x direction? Good. So you see, if you have two forces acting on the same particle and they point toward opposite direction with same magnitude, then you get F minus F equals 0. The total force will be 0. These two forces pointing in different direction will cancel, and that the particle will not have acceleration. Does that make sense? If you have two people pushing the same thing, I'm pulling it here, and my ninja is pulling here. Then at the end, the two forces will cancel. They sum out to 0, and there's no acceleration. Okay? All right. So that is for two forces. Similarly, the y component of the total force will just be the y component of the individual, it will just be the sum of the y component of the first force and the second force. Now, what does it mean graphically? Let me write this somewhere else. So if you have two forces acting on the same particle at the same time, the total force on that particle will be the sum of these two forces. X component is the sum of x component, and y component is the sum of y component. Now, the x component of F1 is here. Okay? The x component of F2 is shorter because you can see the projection is shorter. Right? The y component of F1 is here. It is positive. It is pointing to the positive y direction. For the y component of F2, it is going down. It is negative because it is pointing toward the negative y direction. This is the x component of F1, x component of F2, y component of F1, y component of F2. Yeah. Any question? So if I want to add these two forces, and I want to show you the addition of the graph, my particle. F1x is this long. Okay? And I need to add F2x. F2x is this long. So this is how long F1x plus F2x will look like. Okay? Now, if I want to add the y component, F1y is this long. And F2y is this long. But they are in the opposite direction. So when you add them, you go up and then go down. So the final result will be, this is your total x component, and your total y component is only this big. So if you have these two forces, F1 and F2, acting on the particle at the same time, in this case, it will be this force going this way and this long. Because this arrow has an x component that agrees with F1 plus F2x. And the y component agrees with F1y and F2y. So you know this is a correct arrow. The definition of x component is that you need to have a projection that equals F1 plus F2. The projection is F1 plus F2. So you know this is the correct arrow if you add these two forces graphically. Let me try to be even more precise.